Good day, viewers all over the world. We want to look at linear differential equations, that is, and the theory of solutions. So linear differential equations. Differential equation could be linear and it could be non-linear. So we are starting with linear differential equations. That is, when we have linear differential equations, how do we solve linear differential equations? Then how do we even recognize linear differential equation? Now let's start. An nth order linear differential equation has this form. This is the form of linear differential equation, which is given as 1 there. Where g of x, that is the right-hand side, the right-hand side of the equation, where g of x and the coefficients, these are coefficients. Coefficients, when it is y2, y prime, y prime, it can be, if it is first order, we only have y prime. If it is second order, we have n will be equal to 2. If it is third order, n will be 3, y cubed, y squared. So all these coefficients, b and b subscript n, b subscript n minus 1, up to b naught. Okay, where g and the coefficients, bj of x, that is the coefficients, depends solely on the variable x. Okay, so if you have any differential equation of this form, this is general other different linear differential equations. It is called linear differential equations. Now note, we have to note that if the right-hand side of this linear differential equation is 0, that linear differential equation is called homogeneous. Is homogeneous. For instance, if you have second order differential equation, maybe y prime plus 2y prime plus maybe y is equal to 0. Okay. In this case now, this is a linear differential. This linear differential equation is called homogeneous. It is called homogeneous because the right-hand side is equal to 0. So the solution of this, we only have one part. This solution will only be one part. We only have one part to this solution. And that is called the complementary factor. We only go ahead and find the complementary factor. But if the right-hand side of this differential equation is not 0, then the linear differential equation is called non-homogeneous. Once the right-hand side is not 0, then two solutions will be required. We first go ahead and find the complementary factor. Then we also go ahead and find what is called the particular integral. Okay, so we should be able to identify all this. When we have a linear differential equation that is homogeneous, when we have linear differential equation that is non-homogeneous, when it is non-homogeneous, we should know what to do. So this is the general form of differential equation. So a linear differential equation has constant coefficients. If all the coefficients bj of x in 1 are constant, that is, when we have a linear differential equation, it can either have constant coefficients or variable coefficients. But if all these coefficients here, bn minus 1, b1 up to b naught, if they are all constants, then we know that linear differential equation is that linear differential equation has a constant coefficient. But if they are not constant, then it simply means that they have variable coefficients, and we have different solutions. We have different theory of solutions to all this. When linear differential equation has constant coefficients and when it has variable coefficients, so we should be able to identify all this. So a linear differential equation can be denoted as, that is, if you don't want to write all these stories, we can just denote a linear differential equation as what I'm about to write. So a linear differential equation can be denoted as, we can just say L, we can just say L of y is equal to 5 of x. That is, instead of writing the whole story, we can denote it as this. Okay? And in particular, a linear homogeneous differential equation can be expressed as, I said, when the right-hand side is equal to 0, the linear differential equation is called homogeneous. So when we have, in case when we have homogeneous equation, we just say Ly is equal to 0. This simply means that this linear differential equation is homogeneous. Then whenever we have homogeneous differential equation, we always go ahead and find the complementary factor. The complementary factor will represent the total solution to this differential equation if it is second order. But if you have a linear differential equation that is non-homogeneous, that is the right-hand side is not equal to 0, there are two solutions that will be required. we go ahead and find the complementary factor. We first equate the right hand side to equal to 0 to find the complementary factor, and we go ahead and find what is called the particular integral. As we proceed in this lecture, we are going to understand this better. So I'd love to stop here because of our time. So in the next class, we are going to talk about the linearly independent solution to linear differential equations. So let me stop here because of our time. Thank you.